Here are your solutions to the 2019 real question number 4 without a calculator that was used on the 2019 exam. So let's do it together if you haven't had a chance. It looks a little intimidating, but we'll break it down. So we have a cylinder that's filling up with water. And so the question ultimately is find the rate of change of the volume. So we need a formula for volume. It's right there. And we're going to start there. Notice this was given in the question, so I wrote it down. Now we have too many variables here. So to break that down, I want you to notice in this cylinder, the radius never changes. And so it's a constant all the way through. So the radius going through is how long? So I can plug 1 in right now because that never changes. And if I plug in 1 squared times h, I'm just left with pi h. Now I'm ready to take the derivative with respect to time. So v would be 1, but the derivative with respect to time would be dv by dt. The derivative of pi h would just be pi, but it needs a hook, dh by dt. Now I'm going to plug in the value. So it says when the height of the water is 4. So now is a good time to figure that out. So I'm going to plug 4 in here. So dh by dt, so it's negative 1/10 and the square root of 4. And then what would the units be for the volume? So the units are in feet, so it would be feet cubed for volume per second. And you'd have your answer. All right, part B, that wasn't that bad, right? So part B, when the height of the water is 3 feet, is the rate of change of the water changing? Is it increasing or decreasing? So when you're asked about whether a rate is increasing or decreasing, that means you're going to take the derivative of the rate. So we have the rate. So the height of the water, dh by dt, this is what I have. I'm going to write it calculus friendly. So I'm going to take the derivative of that rate and see when I plug in 3 if it's a positive or negative answer. So the second derivative, we're going to go 1/2 times negative 1 over 10. So that's negative 1 over 20. And then subtract 1 to the exponent. Then we need the derivative of h. We need that hook, dh by dt. Then I'm going to plug in at h equals 3. And I want to know if the answer is positive or negative. So that's a negative value. 3 to the negative 1/2 just means 1 over the square root of 3. It's a positive value. That's negative. How about the derivative up here? Plug 3 in, and you have negative 1/10 times the square root of 3. So if you look carefully, you have a negative times a negative. So that answer is greater than 0. Because a negative times a negative is positive, the rate is bigger than 0. That means what's happening? That means the rate is increasing. Done. Okay, last one, part C. At time t equals 0, the height of the water is 5. Use separation of variables to find an expression of h in terms of t. All right, so we're going to take that. I might have to go a different one here. And I'm going to take this diffie q. And I'm going to separate the variables. So I need the h's on one side. So I'm going to divide by the square root of h. We'll write that calculus friendly in a moment. And then I'm going to multiply by dt. So now they've been separated. That's a point. I'm going to write this calculus friendly. So that's h to the negative 1/2. And then I'm going to integrate this. So separate, then integrate. So I'm going to add 1 to the exponent instead of dividing the reciprocal. Negative 1/10 will just be negative 1/10 t, and then plus c. Done. Then I'm going to plug in the point that they talked about. So when this is 0, the height is 5. So we're going to plug in 0 for t and 5 for h. and then I'm going to solve it. So obviously that's what C equals. So when I plug in 0, it's just that's what C equals. That's a point. Then I'm going to go back into this equation, 2h to the 1/2, negative 1/10 t, and then I'm going to plug in 2 and the square root of 5, or 5 to the 1/2. And then I'm going to get h by itself. So I'm going to divide, and I'm going to make it really simple. I'm just going to divide everything by 2. I'm not going to simplify it. And then I'm going to square root it. Now the height is not going to be negative. So I don't need to worry about positive and negative. It's just positive in front. And then I have this value. And that's it. You did it. Mr. G Math over and out. Thank you for doing your work. Good job. I'm proud of you. Until next time.